Hi guys, welcome back to my YouTube channel. In this video, I want to talk about the complex numbers. We want to introduce complex numbers, and in this video, I'm also going to talk about how to graph complex numbers. Guys, as you can already see that the heading or the main content of this topic is the connection between the complex numbers and the trig functions. But before we start seeing that connection, guys, let us go back and review some basic concepts regarding the complex numbers. So the very first basic concept about the complex numbers is how are complex numbers represented or how are they written out. Guys, the standard form of a complex number, the standard form, which is represented by z, and the standard form is usually written as a plus ib. Guys, sometimes people also like to use x plus iy. So what is the two important key things here that one has to keep in mind, that this is the real part, and any complex number has two pieces, the real part and the imaginary part, and b will be considered as the imaginary part. Guys, we already know that I is an imaginary unit which is equivalent to square root of -1. So this video is not a lesson on complex numbers. I'm expecting that you already know the basics of complex numbers. You also know some history about complex numbers here. I'm just refreshing or rewriting the general form or the standard form of a complex number, which is represented as a real part and an imaginary part. So a plus ib is the standard form of representing a complex number, which is usually represented by z. Guys, real numbers we represent by the capital R, which looks something more like this, and then complex numbers are usually represented by a z. So guys, this is the basic way of writing a complex number in the standard form. Now, based on this, we can graph complex numbers. Now, how do we graph complex numbers? Guys, graphing complex numbers is not too complicated. It is just as simple as graphing any coordinate pair, like an x and a y coordinate. So guys, what we do with the complex, while we try to graph complex numbers, instead of thinking about x and y coordinate, we think of the horizontal axis as the real axis, and the vertical axis, we think of that as an imaginary axis. So this is my x and y, usual x and y coordinate plane, but instead of thinking about the horizontal axis as an x-axis, we think of that as a real axis, and then the vertical axis, we think of that as an imaginary axis. Guys, it is very important for us to visualize or graph these complex numbers, because that is how we can understand the connection between the complex numbers and the trig functions. Okay, so that's why I'm introducing with the graphs of complex numbers, how to graph complex numbers. So guys, if I have to graph a complex number, so the complex number, let us say, is given in a standard form. So what we do usually with the standard form, we identify the real part and the imaginary part. So for example, if I have this complex number, the real part is a and the imaginary part is b. So we kind of identify this or write it down as a coordinate pair. And now, since we have our real axis and imaginary axis, now this represents the real part. That means I have to, let us say, for example, these are both positive, right? Let us say these are both positive. Guys, I'm also going to do some actual examples with numbers here, but let us first talk about the general case. Let us say both of these are positive. That means on the real axis, we have to go a units from the origin. We go a units. Let us say this is a units away from the origin, and then we have to go up by b units. Let's say this is b units. So up here, so we go a to the right, and then we go up by b. So guys, this is going to be the point that identifies a plus ib. So this is my point. Let me call that point, that is z. So it identifies a plus ib, or you can also think of that as a coordinate pair a and b. And that is how we actually plot complex numbers. Guys, that is pretty simple. So what we do usually basically is we identify the real part and the imaginary part, and then we have our real and imaginary axis, the coordinate axis. In this case, we have real axis and imaginary axis, and then we just plot that as a coordinate point. Okay, guys, let me do some examples with actual values for a and b. and then we will talk about how to graph those complex numbers. Okay, so I may have to get rid of this so that we can do some examples here. Let me take a simple example. Example 1. Let's say we have a complex number -1 plus 2i. So if we have to plot this and we want to plot it. So to plot it, guys, the first thing we are going to do is we're going to identify my a, which is the real part. The real part here obviously is -1, and the imaginary part, which is basically the coefficient of the imaginary unit I, and in this case that is +2, right? Guys, once I have my a and b, we already know that this is my real part and this is my imaginary part. Okay, now we can just go ahead and draw the real and imaginary axis. This is my real axis, this is my imaginary axis, and to plot a -1 and b2, so you can already write it down as a coordinate pair, -1 and 2. So -1 means from the origin I have to go left by 1 unit, so it is, let's say, right here, and then +2 means I have to go up by 2 units, let us say, which is right here. So guys, this is my complex number. This is the plot of my complex number is equal to -1 plus 2i, or you can also think of this as a coordinate pair, -1 and 2. Okay, this represents my complex number -1 plus 2i. So guys, it is pretty simple how to graph or how to plot a complex number. Let us look at one more example. What about we have a complex number which is, let us say, -3i. Okay, so we have a -3i. Now, in order to plot this complex number, again, the first thing I would do is I would rewrite this as an a plus ib with a real part and an imaginary part. Obviously, there is no real part here, but guys, we can still write this as 0 minus 3i. And if we rewrite this like that, then we can clearly see that the real part a equals to 0, and the imaginary part, which was clearly visible here as well, is -3. So if you have a pure imaginary quantity, we cannot just simply say that there is no real part of this complex number. Guys, 0 is a valid number, so we got to rewrite this as 0 minus 3i, and then we can see that the real part is 0, and obviously the imaginary part is -3. Now let us go ahead and actually plot this complex number. To plot this complex number, again, I'm drawing this coordinate pair plane, but here I call this the horizontal axis as real, this as imaginary. So it's 0 and -3. So 0 is right here at the origin for the real axis, and then -3 means I have to go down, right? I have to go down 3 units slow. Let us say this is 1, 2, and 3. So this would be my point. Let us call this Z1. So this is Z1 equal to -3i, or if you want to write this in a coordinate pair, it is 0 and -3. So guys, similarly, we can plot any complex number which has a real part and an imaginary part, and each and every number out there can be written as a complex number with a real part and an imaginary part. Okay, so guys, this is the basic introduction of the standard form of a complex number, which is represented with a plus ib or x plus iy, depending on different textbooks like to use different notations. But guys, the key idea is that a complex number has a real part and it also has an imaginary part. Now, how do we plot it? Pretty simple. You kind of first draw the real axis and the imaginary axis, and given any complex number, you identify the real and the imaginary part. You can write this or rewrite that information as a coordinate pair, and then you basically are plotting this coordinate pair as you would do for any real numbers. Okay, guys, this is an introduction to writing the complex or plotting the complex number in the standard form. I will see you in the next video with the other concept related to complex numbers, and then we will start making connection into the trig functions.